Right? These slides show you how to read chemical formulas and how to interpret them. First of all, the first rule in chemical formulas concerning elements, the pure compounds, you uh, you look at big or small letters. So a single big letter means sometimes a singular compound. For example, nitrogen has a formula N, big N. Oxygen, big O. Carbon, big H. Sorry, hydrogen, big H. Carbon, big C. Uh, Phosphorus, big P. Sulfur, big S. Some elements has a little letter beside the capital letter. So iron will be if E, but then the E must be little. Copper will be Cu, but the U then has to be little because otherwise this will be carbon, urane. Another example, nickel will be big N and little e because otherwise this means nitrogen, iodine. Iodine is another element. Kr will be chromium. Sorry, actually, krypton. Mo will be molybdenum. Molybdenum, actually. So the small letter has to be small. You otherwise you confuse it or even find something out which doesn't really exist. So pay attention to that. Now there is something called molecules in which atoms are bounded to each other. We'll consider that more deeply later. But for now, you have to know that sometimes formula are made of several components, several atoms. For example, the molecule NO means we have a molecule called nitrogen oxide, which is made of a singular nitrogen atom and a singular oxygen atom. And it has to be written big N, big O, because otherwise, big N, little o would mean an element, a pure atom, which actually doesn't exist, if I recall it correctly. Now, in formulas, you have also some numbers. For example, you know the formulas of water, which is H2O. That means that in this molecule, we have a singular oxygen atom bounded to two hydrogen atoms. And the number has to be here at the right side, lowered to in comparison to H. If you write it like this, that's nonsense. That's something you will be marked down for at the examinations. So you have to remember how to write formulas. And when it comes to molecule, then you write the numbers of each atom, numbers of each atom for for the particular species, always at the right and down. If you write a number before, like this, then you write it in the same size as the big letters. That means we are considering three singular water molecules which may participate in a reaction. Sometimes you see pluses and minuses at the right upper side of a formula. That means that these compounds have either an excess or a deficiency of electrons. and electrons are negatively charged. We'll look at the atom structure in the coming future, but for now, you have just to learn the formula and what it means. So, for example, H plus and this plus has to be written elevated, not in the same size as of H, not down, not before, but at the right and upper here. Uh, H plus means that you have an atom who has one electron less than it should have according to its atomic model. Now, the atomic model of hydrogen atom predicts that it is made of a proton and an electron. Now, H plus means that there is an electron less. So there is no electron actually in this ion. So this H plus is basically made of a one single particle, which is a proton, which is positively charged. That's why you have a positive charge. If you take Fe3 plus, that's the iron 3 ion, it means that you have an iron atom which has 3 electrons less than the number which is predicted by the atom model. So for each electron you got less, you have got a positive charge more. If you take the molecule, because you have also ions of molecules, OH minus, then that means that if you count the number of electrons with which the molecule OH should have, then you get to the number of 17. Because O has 16 electrons and H has 1 electron. So this molecule should, according to the atomic model, have 17 electrons. But in reality, it has 18 electrons. That means it has 1 more electron than the 17 it should have according to the atomic structure. And due to the fact that electrons are negatively charged, then the molecule has a singular negative charge. I take just another example with negative. S2 minus means sulfide ion. That means this particular atom is in a condition where it has 34 electrons. Normally should have 32. So it has 2 electrons more than what it should have according to the atomic model of sulfur. So the sulfide ion has therefore 2 negative charges, 2 electrons too many. And a case where a molecule has a positive charge, H3O plus, means that the whole molecule has 1 electron less than the molecule should have according to the structure of the atomic model of 3 hydrogen and 1 oxygen together. They should have actually 18. They should have actually 19 electrons, but the molecule has in all 18 electrons. So there is 1 electron less, so there is a positive charge. So remember, each positive charge on an atom or a molecule means the number of electrons missing. Each negative charge of an atom or a molecule means the number of electron which they are too many of. All these particles which positive and negative charges are called ions. And actually the positive ions are also called cations or cations. Now I can't remember how they pronounce it. And the negative charged ions are called anions. Sometimes a formula looks like this. You see there is a parenthesis with a formula and then close parenthesis and an additional number. So that means that this molecule is made by a piece of iron, that would be an iron 3 plus ion, and three pieces which are three nitrate ions. So each and every nitrate ion has the formula of NO3, as you see, N, 1O, 2O, and 3O, and that happens 3 times. So that's why the singular formula for each of the 3 is NO3, and the whole molecule has 3 of them. 1, 2, and 3. So the way of writing it, chemicalish, it is to write Fe parenthesis NO3 close parenthesis 3. Sometimes a formula looks like this. There is a dot here, and then there are a certain numbers of H2O. This molecule looks like this. And the formula means that you have an iron, sulfate, and 6 water molecules. So the way of representing it is to write the component of the molecule without water, dot, and then the number of water molecule which are trapped into the structure. These are actually, this is a salt, and these are actually part of the crystal salt is made of. So remember, big letters and small letters, that's the element. Formula of the molecules. Now remember always to put the number at the right side of the element and down. And if you put numbers before, then you mean the numbers of the whole molecule. There are ions which are positively or negatively charged. Positive charges means less electrons. Negative charges means more electrons. There are the parentheses, which means there are as many molecules, each one with its singular formula indicated by the number which is outside the parenthesis. And there are the dots, which represent how many molecules are trapped into the crystal.